Okay, so this week we're going to talk about Chapter 8, Strings and Vectors. Once upon a time, the only way to have a string in C was what was in fact an array of characters that were treated in a special way. They were expected to have a null character at the end of whatever string was being put into them, and if you put a string or a sequence of characters into that array in a particular way, that null character would automatically be put in there for you. So the null is the delimiting character for a C string. And so they introduced the escape sequence for a null character, which is \0. 0 is the ASCII code for null. So internally, a C string is just an array of characters. And in fact, when you see a literal value between double quotes that we've been using all along, that's actually stored internally as a C string. It's just an array of characters, has a null at the end, and it's the code is automatically, generating that for us. So, since a C string is just an array of characters, we can create a C string by declaring an array some arbitrary size of characters, and we can put C string data into that. As long as it ends with the null, it will be properly treated as a C string. A couple of things that are strange about C strings when we think of them in terms of other variables that we've gotten used to. Although we can initialize a C string, we can't set a new value to a C string that same way with an assignment. And that is treated in a special way because of the fact that internally this is a C string. It automatically generates the null character for us versus another character array if we initialize it the way we would normally initialize a character array. not going to automatically generate a null. And if we leave out the size of the array, this one is going to generate enough to hold the null. So we got 2, 4, 6, 8, 10 is going to make that be size 11 automatically. This one is going to be size 5 because there's only 5 values here. Question? Since it's physically an array of characters, there's a couple of things that we have to do. Well, first of all, we can access each individual character just like we do any other character array. So here we have in display 8.2 a function to convert strings to integers. Might have been useful for your previous assignment. And we refer to each individual digit character in the array with an index, just like normal. But we have to be careful not to wipe out that null character that indicates the end of the string. And in this case, they're manipulating it one character at a time. They have to actually generate the null character and stick it in at the end so that it knows that this really is a C string. So in this code, they're using the A2I function. And if you look in Appendix 4, page 1023, some new string functions that we haven't seen before. I would call these C string functions, but and in fact, you'll notice that most of them are part of the C string library. But A2I and A2L and A2F are not. Those are functions that will convert a string of characters to an integer, a long integer, or a double, although F would lead you to believe it would be a float, but at some point they changed it to double. You also cannot use the assignment operation, which I mentioned, or the equal to with a string. You can't just assign a new value to a string that way, to a C string. And you can't just compare a C string to another string, C string, with the double equal, that is equal to. So there are some special functions for that also in Appendix 4. If you want to put a new value into a C string, you have to use the string copy function, strcpy, or the slightly more sophisticated version, strncpy. strncpy will make sure that you don't wipe out the null as long as you're careful careful to give it an appropriate third argument. That is the maximum size of string that can go into that first C string. And in order to compare two strings, you'll need the string compare function, strcmp. which is also abnormal even for comparison functions, because if it returns true, that means that these strings are different. And only if it returns false are they the same. And the reason for that is because it returns actually a numeric value based on the lexicographic difference between the two strings, which will be a number that will be either positive or negative if any of the characters in the two strings are different from each other. But if they're all exactly the same, then it'll be 0, which we know is the converts to the Boolean value false. And they put some of those other C-string functions on page 459. I recommend going to Appendix 4 if you ever need to look them up. But string copy, string concatenate, string cat will concatenate two strings together, or actually concatenate a second string onto the end of the first string. String length, tell you how long a string is contained in a particular C string. And the string compare functions. So you want to be very careful when using C strings and copying one C string to another. You want to make sure that you don't end up blowing past the end of the array that's supposed to hold the C string, because it'll just keep on going through memory and wipe out whatever comes next if you're not careful. All right, so self-test exercises, page 462. Mr. Gear, you want to take that first one? Which of those following declarations are equivalent?
The bottom two are equivalent, and the top two are equivalent. And then the one in the middle is not.
Okay. Everybody agree with that? Does that look correct to everybody? All right, Mr. Rahim, how about number 2? What C string will be stored in singing string after that code is run?
The doobie-doo to you.
All right, doobie-doo to you. And Ms. Hernandez, number 3, what's wrong, if anything, with that code?
The string cat doesn't check if there's more characters, room to add characters.
Okay, what does that mean? Can you tell me what will happen if we try to run that code?
Get errors.
All right. What kind of errors do you, can you describe it to me? All right, let me see if I can explain it then. So when we declare string var, you'll notice we left the brackets empty. What does that mean? It's just going to allocate enough to store this initial value, which is how many characters? Anybody?
Which the hello.
Yeah, 6 characters. 5 for the hello plus 1 for the null. Now, if we try to concatenate something onto the end of that, we've already used up the entire array that was allocated for string var. So all of this stuff is just going to wipe out anything that comes after string var in memory. And plus 1 null here on the end. And it may work for a little while, depending on if we compiled in any code to check the bounds of our arrays. But pretty soon, all of that memory that we just wiped out is going to have problems. All right, Mr. Gear, let's do one more. Number 4, suppose this strlen, the string length function, had not been created for us. It returns the length of a string argument, and it only has one argument, which is a C string. How would you write that function? Okay, let me stop you right there.
Because it's returning.
It returns the length of a string, so it's not going to be void, it's going to be
int. Sterling. Parentheses. Constant. Character. Name of an array. In parentheses.
Okay,
And an index equals 0. While str index is not null. Plus plus. And you return the index.
hey, does that make sense to everybody?
Yes.
say, for example, we had a C string containing the value ABC. We would come in, start with 0, element 0 is A, so it's not equal to null, so we add 1, so index is now 1. Element 1 is B, that's not null, so we add 1, now it's 2. Element 2 is C, it's not null, so we add 1, it's 3. Element 3 is going to be null, so we return the value 3. ABC has a length of 3. Everything checks out. Make sense? Let's go on. Page 464. C string input and output. So far, we've done a lot of output using the insertion operation. And that's exactly what we were doing every time we output some value in double quotes. That's a C string. We can do the same thing with a C string variable instead. We can also get data using the extraction operator into a C string. And the extraction operation for CN, or any of our standard input streams, will automatically insert the null at the end of the C string for us. Now, it's still going to stop whenever it finds any white space. So if you have a bunch of data that has white space in it, that's not going to help. So we have another function that we can use. The bottom of page 464, the getLine function of the input stream that puts all of the data up to the new line into a C string, and it has a second argument that's the limit, the size of the C string array. It will automatically stop one short of that because it understands that it needs space for a null character. And on page 465, they show you what that means with a short string of 5 characters. It can only actually hold a 4-character string values. All right, another self-test exercise, page 466. Mr. Rahim, number 13. We've got some code, and they want to know what it will output.
Okay, so
So somebody input the value then a new line, some spaces, time is now.
The time is now, the time, the end of output.
Okay. So the CN is going to put something into A and something into B. What went into A?
The
Okay. And what went into B?
time is now.
Okay. No. It's going to stop when it hits white space. It doesn't matter if it's a new line or a space or a tab, it's going to stop. So B is only going to have time in it. So the actual output will be the dash time end of output. Make sense?
Yeah.
All right. Ms. Hernandez, number 14, consider this code. And if I entered a line of input, may the hair on your toes grow long and curly, what would this code output?
May. T. May space T. The lesson.
Okay. So even though my string should be able to hold 79 characters plus a null, we told getLine that we only had a 6-character array to work with, which means the first 5 characters plus a null is going to go into my string, and then we'll get end of output after that. Make sense to everybody? So I mentioned earlier display 8.2, which uses one of the C-string functions to convert a C-string to an integer. As part of the read and clean function. Basically what read and clean does is throw away anything that's not a digit. So the isDigit function, one of the character functions that we looked at last time, isDigit is going to return true if a character is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want to make sure it is a digit and we aren't trying to go past the end of our array for our C string. Otherwise, we'll store all of those characters 1 digit at a time into a string, a C string. And when we're done, we'll plug in a null and convert it to an integer with the A2I function. And then they demonstrate that in display 8.3 with some code that basically lets you enter whatever you want to, and the numeric digits of that get extracted out and converted into an integer, and then it asks you if that's the number you actually wanted or not. All right, now that we know everything about the old way of using string data, they want us to go on to the standard string class. Let's take a short break and we'll pick up on the standard string class when we get back in about 5 minutes or so.